let's go over some properties of pyramids. Now, pyramids, really probably the only exposure you've had to a real life pyramid are maybe the Great Pyramids in Egypt, right? And those pyramids have rectangular bases, but pyramids don't have to have rectangular bases. And we looked into that a little bit in 11.4. We looked at like pentagonal prisms or pentagonal pyramids when the bottom was a pentagon. So a pyramid, if you can read that, is a polyhedron in which the base is a polygon, which we already talked about, and then the lateral faces all have a common vertex. So your base is on one side, and then there's a common vertex where all of the lateral faces meet at. And all of the lateral faces for a pyramid will always be triangles. So if you think about it's something called the net of a pyramid, like if you were to take a three-dimensional pyramid and then lay it all out flat, whatever shape your base is, like let's say your base, I don't know, is a hexagon, okay? If I can draw a hexagon, oh dear. Why did I choose this shape? If that was your base, you have to imagine if this was three-dimensional, all of the sides would kind of come up and then meet at a common point here, and so then if you lay them all out, you would have a pyramid that almost looks like a giant star. You can kind of imagine that, and then a three-dimensional pyramid, you just take all these triangles and then fold them all up, and that's where they would meet, making it a pyramid. And they'll always be triangles like that. The lateral edge is still the intersection of two lateral faces. We've talked about that. The base edge is the intersection of the base and a lateral face. Those aren't again, like horribly pertinent words that you know. You have lateral edges all around the sides, and you have a base edge all around the bottom. Altitudes are still perpendicular. Now this one's a little bit different. Prisms, the altitude was could be on the outside. For pyramids, the altitude's always in the middle. So you have to imagine it like starts at the top and then drops down through the middle to the middle of the base. It is perpendicular. And so a regular pyramid would be straight up and down, perpendicular to the ground. Or in other words, there's a segment that goes from the common vertex down to the base, right at its center. And that's primarily what we'll be dealing with today, right pyramids, ones that stand straight up and down. Slant heights. This will be kind of new today, and this will be important for us. So I talked about this a little bit. I'll do my best to get some visuals here. So if you imagine some kind of pyramid around me, the regular height would be straight up and down, like the top of the vertex straight down to the base. The slant height would be any of the sides, right? The height of any of the sides, any of those triangles kind of coming inward, the height of those sides would be your slant height. Okay, now, finding the slant height, when I made that picture, right, here's like your normal height, pretend, and then here's your slant height, and then you have like your bottom on your base. What kind of triangle do you think that makes? A right triangle, because this height is perpendicular to the ground, and then this one is slanted, touching the regular height in the middle. And so if you don't know a slant height, or you don't know an altitude, you can use, because it's a right triangle, Pythagorean theorem to find it. And we're going to have to do that quite a bit today. So if you had a picture like this, and you needed to find the slant height, really inside of here is this little right triangle, where this is the 321, straight up and down, 300's on the bottom in front of it, and then we're looking for the slant height. Now, when we create this little right triangle, this is inside the pyramid. You have to imagine that, inside the pyramid. How long is this length right here? Well, if the whole entire side is 300, and your altitude goes straight down to the middle, then this would be half of that. And what's half of 300? 150. And now you would be able to do Pythagorean theorem to solve for that slant height. Okay, let's go ahead and do that real quick. So Pythagorean theorem, this is your normal height, 321. That would be, again, like right direct in the middle of the pyramid, from the top of the pyramid straight down to the bottom. This number right here is half of the side length. It's still inside the pyramid. It's just we're trying to look at it two-dimensionally. And then we could find our slant height. That would be your x. So we have some big numbers here. 321 squared plus 150 squared. I typed it all in at once, and I got 125,541. I typed all that in at once, though, so I did not do it individually, which you for sure can do on the blue calculators. I'm not sure about any of the other ones. Somebody might want to double check my math, though, on that. Jacob, are you nodding your head yes? Okay. I got one yes. Am I okay with that number? Great. And then that's x squared, so how do I get x by itself? Square root it. Good. And on mine, I had to round it, I think. 354.3 is what I got. And it's the hypotenuse of that imaginary right triangle inside. It's not imaginary, I guess, but it's the hypotenuse of that, so it should be the biggest number if we did this correctly. Okay, we're going to have to use that today to find the slant height for some of the problems, and we'll have to use it to find the regular height for some of the problems. Can you kind of visualize this right triangle inside the pyramid? You have to really think three-dimensionally here. Okay. Surface area of a pyramid, a little bit different here. How many bases does a pyramid have? How many? One. Okay, so remember for prisms, we had 2B because there were two bases. Well, now there's only one base. So there's your capital B. And then remember, all of your lateral faces are triangles. How do you find area of a triangle, just like a normal triangle? Base times height divided by 2, or 1/2 base times height. And then we have to keep in mind that there are a whole bunch of triangles around here. We have as many triangles as we do sides. So really we have the amount of triangles that our perimeter would be. So we have base times height divided by 2, but times the perimeter, which then looks like this, 1/2 perimeter, and then times the slant height, because that would be the height of the outside triangle. Now I put a 1/2 there. I suppose you could also write it like this if you wanted. However you want to do it. Okay, so capital B, just like for prisms, is the area of the base. And just like for prisms, that depends on the shape of it. So all those formulas up there that say B next to it, yeah, it just depends on what shape it is. If it's a triangle, that'll be different than a trapezoid. Actually, we don't have trapezoidal pyramids. But that would be different from a rectangle. Your capital P still stands for the perimeter of the base. And then this cursive L stands for the slant height. Okay, so remember, surface area is everything on the outside. We wouldn't be using the normal perpendicular height here because that's on the inside of the triangle. We want everything around the outside. So that's what we're going to use the slant height, the ones that are on the outside of the pyramid. Why they chose a cursive L, I don't know, but you're going to see that cursive L, so that means slant height. So we're actually going to jump down to this problem down here, and I don't have a step-by-step layout for you guys on here. I just have the example right there. But we're going to find the surface area of this triangle. So first thing we're going to do, let's find our capital B. Let's find the area of the base. I know it's kind of hard to see on yours because it's really dark. What's the shape of the base of this pyramid? A triangle. So we need to do base times height divided by 2. Ooh, how did I do this? Height. One moment. Did I just assume that was half? Where did radical 27 come from? Oh, I see what I did. Okay, I got it. Sorry. We have to solve for the height here in this triangle. So we're going to do a little bit of Pythagorean theorem real quick just to find the height of the triangle. So imagine this is the triangle here. Each side is 6. It's an equilateral triangle. So these are all 6 around the sides because it has to be a regular triangle. So real quick, I'm going to do Pythagorean theorem to solve for just the height of the base. This length here would be half of 6, 3. And I can do a quick little Pythagorean theorem to find the height of the base. Okay? X squared plus 3 squared equals 6 squared. So again, imagine this being on the ground. I know this is 3. I know that the hypotenuse is 6, and I'm looking for the height. X squared plus 9 equals 36. Minus 9, I get x squared equals 27. Square root, what's the square root of 27? 5 point something, what? 5.19. So like 5.2. Okay, you won't have any again where you have to do that, just keep in mind. But right now, though, that's where the height comes from. So we're going to make our height right here. So we're looking at this two-dimensionally. That little height's going to be, that was a terrible color to choose, 5.2. All right, now we can find the area of the base. You're not going to have any where that happens, I promise. I don't promise, but I'm pretty sure. Base times height divided by 2 for this triangle. Our base is 6. Our height is 5.2. So 6 times 5.2 divided by 2. What does that give us? 15.6. That's your capital B. Okay, I don't have a step for perimeter anywhere up here, but let's go ahead and just find the perimeter while we're here of the base.
Kelly?
Yes. Oh, yeah. Yep, bye-bye. Did you know you're supposed to go to the zoo right now? Oh, they won't let me promise. All right, perimeter of this triangle. So perimeter of the base. Each side is 6 because it's a regular triangle. 6, 6, and 6. What's 6 plus 6 plus 6? 18. Okay, there's your perimeter. So we'll need that in a second. So then the only piece of the formula that I'm missing is the slant height, which we're going to have to use Pythagorean theorem for. So again, you have to imagine this dotted line is like leaning up against the pyramid, and here's our normal height. And actually, this Pythagorean theorem is a little bit different. I lied again, sorry. They give us this lateral edge as 5. This length right here would be half of the side length. So if the full side is 6, how long is this one? 3. And then we're looking for the slant height. So we'll do Pythagorean theorem. X squared plus 3 squared equals 5 squared. So this one's actually like a little right triangle laying against the side. 3 squared is 9. 5 squared is 25. Minus the 9 over, we get x squared equals 16. Square root that, and x is 4. That's your slant height right there. So I did Pythagorean theorem on this triangle to find my slant height. It was set up a little bit different than the one before. The other one, they gave us the perpendicular height in the middle, so it was like a 3-dimensional triangle. This one's laying up against the side. It's like half of the side. And then there's our B, P, and L, so then we just plug it all in. B, P, and L, we plug in. Our B was, I already forgot, what was our capital B? I can't see it now. What was it? 15.6. Our capital P was 18, that was your perimeter. Your slant height was 4. So then your surface area, here's your formula. Our B is 15.6. Our P is 18. Our slant height is 4. I think we can do this in our heads. Ready? What's half of 18? 9. What's 9 times 4? 36. You can type it in if you want, but we just did it in our head. Half of 18 is 9. 9 times 4 is 36. You could also type in 18 times 4 divided by 2. And then 36 plus 15.6 is what in the end? What is it? Units squared. Okay. Questions on surface area. That one was a little more complicated than the ones we normally get. Okay, volume then. Volume is just a different formula. It's almost like the prism one, but we cut it by a third. So volume for a pyramid, you're going to see me write it like this. Area of the base times the height divided by 3. So capital B is still area. Oh, and this was a typo on the sheet in case you didn't notice. I wrote on there formula for video of a pyramid. I don't know if I was like watching a video, but it should say volume, not video. Sorry. What was the surface area on the last slide, Morgan? 51. Thank you. I'm going to type. Okay, and we're going to find the volume of that exact same pyramid. So on this pyramid, we found the slant height already. What was the slant height again? That we found, what was the slant height? The 4. And then we need the up and down height, so the perpendicular height. So I'm going to create my little right triangle in here. This was half of the side length, so half of 6 was 3. And then I'm looking for the normal height using Pythagorean theorem. So now we're looking at like a 3D right triangle inside. This is 4. This is what I'm looking for, and then 3 is across the bottom. So Pythagorean theorem, x squared plus 3 squared equals 4 squared. Three squared is 9. 4 squared is 16. Minus 9. 7. Square root of 7. 2 point something. 2.6, and that would be your overall height. That's your H. We already found capital B. Capital B was 15.6. We already found it. So then from here, we plug in B times H, the height, divided by 3. Right, here's your volume formula. And I was just plugging it in. Capital B, the area of that bottom triangle was 15.6. We found that on the last problem already. Your overall height is 2.6, and then divided by 3. 15.6 times 2.6. 15.6 times 2.6 is 40.56. And then divided by 3 is 13.52 units cubed. Now, again, you normally don't have to do Pythagorean theorem quite that many times. Usually you only have to do it once. Okay, before I ask for questions, let's do one more, and then I'll kind of give you a chance to sort of mull through what you learned. Okay, so on the next problem, we're going to find surface area and volume. Here are your two formulas. Here's surface area, capital B plus 1/2 capital P times the slant height. Here's your volume formula of a pyramid. And again, you'll get all these formulas on the test. You just have to know how to apply them. So there's your two formulas. So we need a capital B, we need a capital P, the perimeter, we need a slant height, and we need a normal height. What's the shape of the base? Square, perfect square. And these are all going to be regular pyramids. So the bottom or the base has to be a regular polygon. Like it's going to have to be equilateral. It has to be for the ones that we're doing. So our capital B is the area of a square. Base times height. 10 times 10. What's 10 times 10? 100. There's your capital B. Capital P is the perimeter of the square. Each side is 10, and there are 4 sides. So what's the perimeter of the square? Riley? 40. Again, all of your bases for these pyramids will be equilateral, regular polygons. We have the regular height. The regular height is in the middle, 12. And so the only thing we need to solve for is the slant height before we start plugging things in. Question? Because it's a square, and you find area of a square by base times height. 10 times 10. Any other questions before I keep going? Okay, so we're looking for the slant height over here. So I'm going to draw on my little right triangle. This is what I'm looking for. This would be half the side length, which would be what? 5. Half the side length would be 5, and then I do Pythagorean theorem on that little triangle. So again, this is like the 12. This is what you're looking for, and then 5 is along the bottom. It's inside the pyramid. So Pythagorean theorem here, 12 squared plus 5 squared equals x squared. 12 squared is 144. 5 squared is 25. $144 plus 25 is what? Besides Riley, 144 plus 25 is what? Nathan?
169.
169. That's x squared, so make sure you square root it. And that should be a whole number, a perfect square. Square root of 169. 13. That's your slant height. Because that would have been this guy right here, right along the edge. All right, now we're ready to start plugging things in. But before I do that, are there any questions? Where did B come from? How did you get that perimeter? The height was given to us, right smack dab in the middle. And then I did Pythagorean theorem to solve for that piece. Any questions? Okay, surface area formula, B plus 1/2 PL. Here's your B, 100, 1/2, perimeter was 40, slant height was 13. You use the slant height for surface area because you want like the outside stuff. Half of 40 is 20. 20 times 13 is 260. Yeah, because it doesn't matter what order you multiply in. Yep. Yep, good question. He said, I get that question a lot, actually. You can take, like, do you have to multiply these first and then cut it in half, or can you multiply this by a half? Yeah, multiplication is any order, it doesn't matter. And then 100 plus 260 is 360 centimeters squared, because it's area. Again, don't get fixated on labels. If you're good, I want the numbers. I want to make sure that you can calculate it, and that's what I'm looking for on a test. Volume, different formula. BH divided by 3. The area of the base was 100. Our normal height was 12, and then divided by 3. 100 times 12 is 1200 divided by 3. It's 1200 divided by 3. 400. 400 centimeters cubed because it's volume. That's probably a little more comparable to something that you guys would have to deal with. The first one, there was a lot of Pythagorean theorem happening. You're not going to have to do Pythagorean theorem that many times. Just once, probably, if necessary. Questions on that? Okay, we're going to do one problem real quick, kind of like the problems that we had for the prisms, where you're given the volume, and then you're looking for the height. So here's your volume formula. We're given the volume being 14. It's right here. Volume equals 14. We don't know the height, so I'm going to leave the h there. And we need to solve for b. We need to calculate b. B is the area of the base. Tori, what shape is the base in this problem? A triangle. So then we find area of a triangle using base times height divided by 2. Base times height divided by 2. And those are given to us. Base times height divided by 2. Base times height divided by 2. 4 times 3 divided by 2. So again, capital B is the area of the base. Like, what is the base encompassing here? And that's 6. So I really want to stress to you that capital B doesn't just mean base. Like, it's not a single number that you can pull from the problem. You have to calculate it every single time. And then final step here, we just divide by 6. And that's not going to be a whole number. That's okay. What do we get for our height? 14 divided by 6. Is anybody typing in 14 divided by 6, or are you trying to do it mentally in your head? I don't know. Brock? 2.3 feet. Good. So that's kind of like what we did on the front side of the 11.5 worksheet. We'll do one problem real quick where we get similar solids. That's what we did yesterday with the scale factor and cubing the scale factor. Can I keep going? Okay, this one says A and B are similar. Find the volume of pyramid B. So we're going to set up a proportion and solve. Step number 1, find the scale factor. So we're going to use the 8 and the 6 to find the scale factor. And we can simplify that. Take a 2 out of the top and bottom, and what does 8 over 6 simplify to? What? 4 over 3. Okay, that's your scale factor. Now, who remembers what we have to do with the scale factor before we set up our proportion? Besides Morgan, who remembers what we have to do with the scale factor before we set up our proportion? Cube it. Take 4/3 and cube it. So we're going to cube 4 and we're going to cube 3. Because volume is units cubed. 4 cubed is 64. 3 cubed is 27. And now we can set up our proportion using this fraction. Now I did big over small, so I have to stick big over small when I plug in the volumes. So mine would look like 96 over x. If you did 6 over 8 and did little over big, you would just want this fraction flipped. Go ahead and cross multiply that on your own. And Jerry, could you write this down? All right, Nico, what'd you get? 40.5 meters cubed. Good. That was just like a problem that we did on yesterday's notes. Okay, last little thing we're going to look at here is a composite solid. And what that means is, and we looked at composite polygons way back a long time ago. That just means you're taking two solids and you're putting them together. So remember when you were little, you probably had some kind of like blocks that you played with when you were little. Mine were wooden. And then you could like stack them and create different things. So basically on this problem, they took like a cube box or cube block, and then they took this little triangular pyramid, or I guess it would be a square pyramid, and then stuck it on top. And now I want to know the full volume. Well, there's no formula for volume of this shape, but we can find the volume of the bottom piece and the volume of the top piece, and then add those volumes together, and that would create the volume of the entire thing. So let's first find the volume of the bottom prism. Okay, that is a prism on the bottom. Volume of a prism, the formula was just area of the base times the height. So I want you to try and just ignore for a second this little roof on our house. Like, just ignore it. And just look at the box down here. Area of a cube. Volume, sorry. What? What? Sorry, I did not understand the question. This is a composite solid that like there's no formula for a prism and a pyramid put together, so we're going to find the volume of the prism and the volume of the pyramid and then add them. So right now I'm just finding the volume of the prism on the bottom, which is this formula. Okay, so our capital B is the area of the base. The base is a square. Base times height. What's base times height here? 6 times 6. 36. There's your capital B. And then your height of the cube is what? 6. So for the volume, we just take 36 times 6, and that's it. What's 36 times 6? 216. All right, that's the volume of the bottom piece. And I would have gotten that too. Remember way back when you guys learned length times width times height, that would be 6 times 6 times 6. You would also get 216. Okay, the top piece is a pyramid, which is a different formula, because the top piece only has one base and then meets at a point at the top. So that formula is that we learned today, BH divided by 3. Now, the area of the base, what's the shape of the base of the pyramid on top? Square. It's the same square as it was down here. So we already found capital B. Capital B is 36. We already found the area of this base. 6 times 6. Has the same dimensions as the base on the bottom. And then your height of the pyramid, 6. So then our volume formula is 36 times 6 divided by 3. So 216 divided by 3. What do we get? 22. Okay, so that's this volume up here. So the volume of the cube is 216. The volume of the pyramid is 72. So then the total volume would be the two volumes added together. 216 plus 72. Which is what? 288 meters cubed. Okay, I think what I would like at this point in time is for you to grab out your 11.6 worksheet. And we can go over maybe a problem together. Because there's kind of a lot happening right now. Yeah, that's right, you can move this. Now, the directions are a little bit different. The first two problems on your assignment, the first two, so go ahead and grab that 11.6 worksheet out in front of you if it's not in front of you. The first two problems only ask, if you read the directions, they only ask for surface area. They don't ask for volume. So you will only be using the formula capital B plus 1/2 P times L. Okay, this one will not require Pythagorean theorem. This one will. Number 2 will. Because on this one, you don't know the slant height, so you're going to have to use Pythagorean theorem to find the slant height. Maybe we can do that one together. And then 3 and 4. 3 and 4 only ask for volume. So 3 and 4, you don't need to do surface area, you only need to do volume, which is this formula. You might want to write that down next to the problem. And neither of those will require, let me make sure as I'm looking at it, yep, neither of those will require Pythagorean theorem, neither of them. The height's there, like this height is 9. This height is 7. Okay, let's look at maybe number 2 together. Real quick before you go. I promise we won't do any new notes tomorrow. I know it's draining. I know you're tired. I know it's boring. You're being troopers and I appreciate it. Okay, we need a capital B, a capital P, and an L. Let's do our capital B first. Now, what shape is the base here? Hexagon. So we're going to do apothem times perimeter divided by 2. Apothem times perimeter divided by 2. So we do not need the 11 for a second. Let's just not even look at the 11. The apothem is 5.2. What would the perimeter be of the hexagon? 6 times 6 sides. 36 divided by 2. 5.2 times 36 divided by 2. 5.2 times 36 divided by 2. I'm getting 93.6. That would be the area of that hexagon. I did apothem, 5.2, times perimeter, 36. Because each side is 6 divided by 2. Capital P, the perimeter, I already found it. The capital P was 36. 6 times 6 sides. Now the slant height is what I need. The slant height is not 11. That's the normal height, the perpendicular height. I need the slant height. So I have to do Pythagorean theorem here to find this length, if you can imagine it, going back up to the top. So there's like a little green triangle on the inside. Like this distance here is 5.2. If I was the height, I would be 11, and I'm looking for the point where the 5.2 ends up to my head. Pythagorean theorem, 5.2 squared. We don't have to cut that in half because this is literally 5.2. Plus 11 squared equals x squared. 5.2 squared is 27.04. 11 squared is 121. That's 148.04 once you add them together. I hope you're following so far. Square root that. And I'm getting, it's rounded, so about 12.2. If you round correctly, that's your slant height. Okay, that's the only one you have to do Pythagorean theorem on. The rest of them you don't have to. Let's plug it into surface area real quick. Surface area is capital B plus 1/2 PL. Capital B is 93.6 plus 1/2. Oh no, I'm running out of space. P is 36. L is 12.2. I fit it in. Okay, 1/2 0.5 times 36 is 18 times 12.2 is 219.6. So that was all of this. Add it to 93.6 and I get 313.2 kilometers squared. Oh my goodness. That problem probably takes the most work. Okay, so the number 1 is also surface area. No Pythagorean theorem on the rest of the 4 on the front. No more Pythagorean theorem on the front. Please don't do it, because then you're going to get a wrong height. You still have a couple minutes if you wanted to get maybe like something on number 1 done. Like you could find the area of the square on number 1, like the base. The slant height is given to you. You could find the perimeter. Those are all regular polygons on the bases too. So like number 1, that has to be a perfect square.